Hey guys, welcome back. I hope you had a spectacular weekend, that you enjoyed it, especially some of the nice weather that we had. Um, I hope you were able to watch or maybe tune in live to the challenge that I completed on Friday with the Bean Boozled jelly beans. If you didn't watch it, 8 of the 10 jelly beans that I got were very disgusting flavors. So I lucked out on that one. But I guess at least they weren't all disgusting. So that's the positive side of that. Anyway, I do have the results from Math Olympics event number 6. So make sure that you read if your class won any of the aspects or parts of event number 6, and make sure you cast your vote as to which teacher, what challenge you would like them to complete. Based off of some students' recommendations from last week, there have been some additional challenges added, so make sure you get that vote in if your class is one to choose there. So, as you can see today, I did decide to get my hair up out of my face a little bit. It's looking poofy. It's definitely doing something funky. So, but I couldn't stand. I needed to get it off my forehead for a day and just let it stop hanging down. So going back to a little bit of what I normally look like, at least for today. Future, I don't know. We'll see. I was really hoping to get a haircut here soon, but maybe out of luck on that for a while. Anyway, today, Mr. Sorrell's trivia question deals with favorite numbers. So, in 6th grade, I'm not going to necessarily say that my favorite number was picked at this point, but it was definitely confirmed and decided by 6th grade what my favorite number was. And this is the grade that, like, all of my sports numbers were this in particular number. Like every sport that I played, the jersey was this number. I just really started to favor this number all the time. So simple question today, but I want you guys to try to basically take a guess at what my favorite number is. So I'll give you a hint. It is in between 0 and 99 because it had to fit on a sports jersey. So in between 0 and 99 is my favorite number. Now, some of you may know because I think I've mentioned it in class before, but I want you to go ahead and take a stab at that one. All right, and I want to know from you guys what your favorite number might be, and you can tell me the reason what it is or not. It's up to you. But I do want to know if you have a favorite number or a lucky number, in that case. Okay, so go ahead and give me your best guess to those questions right now. All right, guys, so my favorite number of all time is the number 22. Couldn't exactly tell you why other than I liked the idea of the number being the same, and I liked number 2. I have multiples of 2, multiplied by 2, divided by 2. So there was a little bit of math behind it, but I just loved the number 22, and have always been in love with that number. So I will occasionally try to throw it into some problems for you guys. I don't know if you guys have noticed or not. But I'll try to work it in from time to time. Gotten a little bit away from it, but still really like the number. So that's my favorite number. I look forward to hearing and reading what you guys have to say and why that's your favorite number. So today with Envision 11.6, we're going to talk about dilations. Now notice that this is 11.6. We are skipping over 11.5. I just feel with the limited time that we have left with assignments and instructional new content. Instructing on new content, that I wanted to make sure that we covered kind of some of the more important aspects in those topics. So one of them that we're going to talk about is dilations. Now, dilation is another type of transformation that we're talking about here. Okay. Now note that so far the transformations that we've covered have only moved the object or the figure somewhere else. So we've changed the position of them. Well, dilation is not changing the position of the object or the figure, but instead it's creating a new figure that's a different size. So it's going to be like a similar figure, but it's a different size, so it has different lengths to it. Okay, so that's what we're talking about when we're looking at dilation. We'll dive more into that in just a moment. So we have a landscape architect who's designing 2 open green spaces for an area of a park. She designs the larger space so the length of each side is 3 times the length of the corresponding side in the smaller green space. Where should the architect draw the larger green space? So down here we have the smaller green space, which is in the shape of a rectangle. And the architect wants to create a larger green space in this area that's going to be 3 times the length of each side. Okay. Well, you could look at this, and of course you could figure out what the length of each side was, multiply by 3, and get that new the new dimensions of the image. And that's kind of exactly what a dilation is going to do. So for a dilation, we have to have what's called a scale factor. So since we're multiplying all the sides by 3, our scale factor is going to be 3. And I'll dive more into what a scale factor is here in a moment. But that dilation is going to be the transformation that moves each point along the ray through the point starting from a fixed center, and then multiplies the distances from the center by that common scale factor. Now, that's a lot of different vocabulary and jargon that's in there, and we're going to break that down. So it's a transformation that moves each point along the ray through the point starting from a fixed center. Well, our fixed center, and here's our original, and we're going to call it triangle A, B, C, D. That fixed center is going to be the origin. Okay, so the origin down here and the origin down here. And you can see that we have all these rays. Now a ray just has a starting point and then a line that continues on and on forever in one direction. So we have rays extending from the origin, touching each point of the original image of A, B, C, D, or the original figure, to the image A prime, B prime, C prime, and D prime. Well, notice that this ray travels along and touches A and A prime. This one's specific to B and B prime, and then C to C prime, and D to D prime. Notice how the original image and the original figure and the image figure, the points are on the same ray. Okay, so then those distances, you multiply them from the center by that scale factor. Now, a scale factor we represent as R. Okay, and the scale factor is the ratio of the length in the image to the corresponding length in the pre-image. Once again, that might sound a little confusing, but to break it down, you're creating a ratio of a length of one of the sides of the image or the new figure over the original, and that gets you your scale factor. I'm going to break that down for you just a little bit. So I'm going to use the example A prime to D prime over A D. So A prime to D prime, if you were to count out the units, the y-axis for A prime is 6, the y-axis for D prime is 3. So 6 minus 3 is just 3, so it's 3 units long. I'm going to put the 3 up in the numerator. The distance for A to D is just 1 unit. Okay? So then our scale factor, we're going to simplify. We're not going to leave it as an improper fraction. 3 over 1 just gets us 3. Well, we know this has to be true because it tells us up here that the scale factor was 3, that we multiplied by 3. So if we took the distance AD, which was 1 unit, and multiplied it by 3, that would get us the distance from A prime to D prime, which was 3 units. Okay? And this would work for all of them. If you chose A prime to B prime to A to B, it would also work that way. Okay? Keep following along with me here. So this also works for all of the ordered pairs. So let's look at the ordered pairs in our original points and see if there's a way that we can get what the ordered pairs are going to be in the image. So we have A, the ordered pair was 1, 1, 2. Okay, we can verify that down here. Well, let's look at the ordered pair for A prime. Well, the ordered pair for A prime, we have the x-axis as being 3 and the y-axis as being 6. So I'm going to put 3, comma 6. Is there any type of relationship that you guys can notice right now between the original point and the image point? So A and A prime. Maybe you guys see it, maybe you don't. I'm going to do another one. So let's look at B. So we have 3, comma 2. Well, let's look at the ordered pair for B prime. Well, the ordered pair for B prime, the x-axis is 9 and the y-axis is 6. So I'm going to put 9, comma 6. Now I know some of you might be looking at that and thinking, well, what kind of pattern could be identified from this? What kind of relationship is there? Do you guys see a pattern forming from A to A prime and now B to B prime? Well, if you do, that's great. If you don't quite see it yet, I'm going to reveal that pattern. To go from A to A prime and B to B prime, you multiply the ordered pairs by your scale factor. Recall our scale factor is 3, and it even said it up here. Our scale factor is 3. Well, to go from 1, 2 to 3, 6, you multiply your x and your y-axis coordinate by 3. 1 times 3 gets you 3. 2 times 3 gets you 6. And the same thing down here. 3 times 3 gets you 9. And 2 times 3 gets you 6. Well, let's see if this works for the other one for C and D. Well, here's our ordered pair for C. The original ordered pair is 3, 1. So what can we predict or assume that the ordered pair for C prime is going to be? Well, if we use our scale factor, we're going to multiply the ordered pairs by 3. So 3 times 3 is 9. And 1 times 3 is 3. Well, let's check this out. What is the coordinates of C prime? Here's C prime. Our x-axis is definitely 9, and our y-axis is 3. So it worked out. Let's keep going. What about 1 and 1? So for D, to get D prime, we would multiply the x and y by 3, and we would get 3, comma 3 for D prime. Is this true? Well, let's look at our point. So D prime, the x-axis is 3, the y-axis is 3, so this must be true. Okay? So to get any ordered pair, to get the new ordered pair on the image for any of the primes, you would just multiply by the scale factor, whatever the scale factor is. Let's look at this next one. So as I mentioned before, the corresponding side lengths are just going to be multiplied by the scale factor. So AD, to get A prime to D prime, you would multiply by 3. Because notice that we are changing in a dilation. We're changing the length of each side length, but we're not changing the angle measures or the orientations or the shape. We're just changing the side lengths. So AB, while AB was 2, A prime to B prime would be multiplied by 3, so that would be a distance of 6. 2 to 6. BC was 1, so B prime to C prime would be 3. CD was 2, so C prime to D prime would also be 3. I want you guys to go ahead and head on to part 2.